When we look at the universe, one of the first things we notice is the presence of a surprising order. Planets move in well-defined orbits, light always travels at the same speed, and particles interact according to specific rules. Moreover, all of this can be expressed with remarkable clarity through mathematical laws. This gives us the impression that the universe is built upon a solid and stable foundation. But here's the interesting part. The true reason behind this order is that space is not as empty as we think. In reality, space is filled with invisible energy fields that influence everything around them. In physics, these are called quantum fields. These fields hold atoms together, determine how forces operate, and, in short, form the foundation of all physical laws in the universe. In other words, the universe as we know it is entirely shaped by the behavior of these unseen fields. However, in recent years, some findings reached by scientists suggest that this order may not be as permanent as we once thought. Because one of the most important quantum fields in the universe, the Higgs field, may not currently be in its most stable state. In other words, the universe may exist in a temporary and unstable energy state. In physics, this situation is called a false vacuum. Although everything appears perfectly balanced from the outside, the universe may not be truly stable, and this poses a potential threat to the entire universe. Because a quantum field trapped in a false vacuum naturally tends to transition to a lower and more stable energy level. If such a transition were to occur, it would not be a small change. It could mean the destruction of the entire universe, and the most unsettling part is this. This process may have already begun. At this very moment, while you are watching this video, the Higgs field may have reached its true energy level somewhere in a part of the universe we cannot see. This could have caused the formation of an energy bubble in that region. Inside this bubble, completely different physical laws would apply, and it would expand by pulling the surrounding space toward itself. In short, an entirely new universe could be born. But is something like this really possible? Is the universe truly in a temporary state of balance? To understand this, let's look at a simple analogy often used by physicists. Imagine placing a ball inside a shallow pit. From the outside, the ball appears perfectly stable, but if you dig a deeper pit right next to it, you realize that the ball is not actually in a very safe position. Even a small disturbance could cause it to fall into the deeper pit. This is exactly how physicists describe the current state of the universe. The shallow pit represents the false vacuum, while the deeper pit represents the true vacuum. So even though the universe seems to be functioning just fine right now, this state may not last forever. If the Higgs field transitions to a lower energy level, this would not simply be a transition, it would mean rewriting all the rules of the universe. Even worse, it is impossible to predict when or where this transition might occur, because this process is governed not by classical physics, but by the inherently random nature of the quantum world. In the quantum world, things do not work the way we are used to. In classical physics, you can calculate where a ball will land when you throw it into the air, but in the quantum world, you cannot say where a particle is only where it is likely to be. You can think of this like rolling a die. While the die is in the air, you cannot know which face will land upward. All possibilities exist, but none have yet become reality. The Higgs field may exist in a similar state of uncertainty, and there is something that makes this situation even more dangerous: quantum tunneling. Under normal conditions, a system must overcome an energy barrier to move to a lower energy state. But in the quantum world, particles sometimes behave as if the barrier does not exist at all, passing straight through it instead of going over it. This is a completely random process. If the Higgs field were to undergo such a transition, a vacuum bubble would form. If this bubble were very small, it would disappear almost instantly. But if it exceeded a certain critical size, it would become self-sustaining and begin expanding at the speed of light. And everywhere it expands into, the physical laws we know would become completely invalid. We would not even be able to detect this bubble approaching, because its expansion speed would be faster than any signal or information could reach us, much like the event horizon of a black hole. However, it's important to understand this. Vacuum bubbles are not black holes. Black holes consume matter. Vacuum bubbles, on the other hand, transform space-time itself. If we were to enter such a bubble, particle masses would change, atoms would become unstable, and the matter we know would cease to exist. Time might flow differently, light might travel at a different speed. Although such an environment would be fatal for us, it would be perfectly stable within its own rules. For this reason, some theorists believe that such a transition could represent the birth of a new universe. In fact, our own universe may have formed in exactly this way. So what we call an end could, from another perspective, be the beginning of a completely new universe. At first glance, all of this sounds like science fiction, but an experiment conducted in 2023 showed that this scenario is physically possible. Scientists were able to simulate a false vacuum state in the laboratory by creating a quantum system at extremely low temperatures. The system remained unstable for a while, then a small energy bubble formed and gradually expanded, affecting the entire system. The results were published in the journal Nature Physics. So could humanity trigger such a process deliberately? Could the Large Hadron Collider at CERN destroy the universe? The short answer, no, because the energy produced there is billions of times lower than what would be required to destabilize the Higgs field. Moreover, nature has been producing far more energetic collisions for billions of years. If such events could trigger a false vacuum collapse, the universe would have already been destroyed. The probability of this happening naturally is also unimaginably small. According to calculations, the estimated time required for a false vacuum decay to occur lies between 10 to the power of 88 and 10 to the power of 241 years. That is many orders of magnitude longer than the current age of the universe, beyond anything we can realistically imagine. In short, the universe is safe for now. But completely safe? That question still has no definitive answer.